Next we have James Kent from University of Texas at Austin, who will present Neurosynth Compose, New Frontiers in Neuroimaging Meta-Analyses.
All right.
And are your slides uploaded?
Yes,
They are. Okay.
they should be uploaded. It looks like it. I see them. Okay. Well, I hope you're ready to hear the word neuro and a bunch of acronyms that you are going to be quizzed on afterwards. So get ready. Today, I'm going to be presenting Neurosynth Compose, New Frontiers in Neuroimaging Meta-Analyses from me and my PI, Alejandro de la Vega. We're in the Neuroinformatics lab in Austin, Texas. I have, is it supposed to, okay, this one. Oh, I see. Yes. That'll work. Okay, I have no disclosures. Before I get started talking about the platform, let's just give a brief overview on why we want to do meta-analyses in the first place for neuroimaging data. First of all, there's so much data being published. There's thousands and thousands of papers out there for so many subtopics within neuroimaging. It's impossible for researchers to keep up with it. And meta-analyses provide a convenient way to help summarize all of that literature. It also helps with generalizability. Gone are the days of taking your simple sample of 20 affluent, educated people that are in the university and deciding on a topic and saying, okay, we've now settled on the topic. We want to be able to generalize across our populations, and meta-analyses are a way in which we can help generalize across our very specific samples. And thirdly, another reason why we like to do meta-analyses is power. So again, with those 20 subjects, it's typically not enough people to reliably detect an effect in fMRI. So meta-analyses provide a way for us to boost those numbers up by having additional studies to add to our conclusions. And what we want to do is that we want to make meta-analyses a part of the research cycle. We want to make meta-analyses so easy that it's just something that you do as a part of your lab to continuously add to the overabundant amount of research which we already have. And the main limiting factor towards researchers being able to do this is meta-analyses are really time-intensive and just straight up difficult, and in some ways that it doesn't need to be. Just to outline some of the time it takes to run a meta-analysis, along the top here is the number of months. You can have a planning stage for your meta-analysis, or systematic review, as it's called here, referring to the overall process. Planning can take a few months. Searching for the relevant literature can take a few months. Now, screening the literature, this is the one where it takes so long. This can take 6 to 8 months of your life in order to find all of the relevant literature and to determine whether or not it is actually relevant for your meta-analysis. Then data extraction is going to take a few months. Quality assessment is going to take a few months. Data analysis can also take a few months. Writing and reporting, you guessed it, another few months, and then reviews and revisions are yet another few months. So looking across this process, you're looking at least 2 years of work for running a meta-analysis. And what I'd like to propose is Neurosynth Compose, which can help make some of this shorter. And even more than that, I want to propose that we can create living, breathing meta-analyses. So instead of publishing a meta-analysis, having it be in a journal, and then all the papers are locked away in their, however that you're organized in your lab, we want to make it so that they're open and that you can look at them and then you can update them and be able to add in new research as it comes in order to update your results instead of having to start from square one over and over again. So with that, now I'll say, hey, it's Neurosynth Compose. You might have heard of Neurosynth, which was a way of automatically extracting coordinates from a large swath of literature and putting that all into a database, which was really nice and really cool, and people really liked it. The main complaint was that people couldn't update or edit any of the coordinates that were automatically extracted because there were errors. And Neurosynth Compose allows you to take all of those automatically extracted coordinates, and we've added to them as well. So original Neurosynth maybe had about 14,000 studies in part of its corpus. We have now doubled that size. And we give the user not just the ability, but the pathway to edit all of those coordinates in which we have automatically extracted, and make those edits shareable for the larger community. So as you do a meta-analysis, and as you improve the database, you improve it for everyone else that would also use that database. So here's a little bit in the background. This is where I was going to talk about some acronyms. It's a little bit much on the, let's see, how do I get the, I guess here's the mouse fine. Yeah? How do I get the bottom left? Oh, I see, pen and laser point. Laser, there we go, thank you. So on the left here, this is the user interface. So this is you, the faceless user. I promise we do actually view you as having faces, and I would love to talk to you afterwards if you have a use case. I want to collaborate. And we have you interact with our front-end interface called Neurosynth Compose, where you will specify your meta-analysis, where you talk to this. This is where all the programming happened. Another neuro word where we keep all of our studies on a database called Neurostore. And you specify your meta-analysis, and we created an open data standard called neuroimaging meta-analysis data structure, creates a bundle, which submits it to NIMARE, which is the neuroimaging meta-analysis research environment, created and really put forth by Taylor Sallow. And from there, you can share the results with your collaborators, or you can keep them private to yourself for right now indefinitely. And from there, it just creates an entire ecosystem where you can search those, even existing meta-analyses, or create new ones. And all of these papers come from PubMed and NeuroVault and other places in which we actively extract from. Okay, and just to showcase, here's an example of, oh, hey, we ran a meta-analysis and it works. And we show the maps here that you can look at in our interface. And we do either soft thresholding or hard thresholding, depending on how much of the context of the statistical image that you want to see. But yes, this is showcasing that it works, and we run meta-analyses. So a little bit about the data set. We have over 38,000 studies on the platform currently. Here they are broken down by year. We peak at around 2,500, but per an individual year, and as we get further along into 2025, I imagine this number will grow as well. So these are just all of the papers in which we have found tables that might contain coordinates in them that we've ingested onto our database. And so those are all right for you to search and edit and include for your meta-analyses. And they also include many topics. So based on some of the journals that we scrape, there are a number that are related to schizophrenia, but we also have lots of working memory, depression, Parkinson's. We have a bunch of data that covers a lot of medical diagnoses that can be useful for your perhaps subfield or niche question. And now going on to usage. Where's the tiles right there? We have over 2,000 users, and we're growing, and they exist over the United States, Canada, South America, in Asia, and in Europe. So come join the community. We want to hear from you. We do have something that's in beta, so we are still going through active validation, but we are using large language models to help extract features from the text that we have scraped. So we are looking to have useful things for people to filter and curate their to curate the studies that they want to include in their meta-analyses. So this is one of the elements that we believe will help shorten that time to go from planning your meta-analysis to executing that meta-analysis, so you can screen your studies quicker using this extracted information. That is our hope. So you have things about the tasks and things about the participant demographics, and upcoming coordinate-based meta-analyses are great. That's what we've been doing, but image-based meta-analyses are the gold standard, and that is what we want to do with NeuroVault. With all of that, this is not a me effort, this is a we effort. There is so many people that contributed to this project. Nicholas Lee, he's our front-end developer and has made the website so much easier to use. Taylor Salo, as I mentioned, developed Nightmare. Julio Peraza has worked on a lot of the image-based meta-analysis, and everyone else has helped out with the conception and the annotation of data, and with just providing valuable feedback. So with that, I want to say thank you. Are there any questions? And I would like to collaborate.
Thank you so much, James, and congratulations. Unfortunately, we don't have time for questions, but there are questions in the app. I'm sorry, in the interest of time, we have to move on to the next speaker. Thank you so much, James.